have Dr. Balázs Szigeti with us here today, who, as we've been discussing, has a number of very impressive degrees. So a bachelor and master's in mathematical physics from Imperial College London and a PhD in computational neuroscience from Edinburgh University. He's been involved in a number of very exciting projects, including the Open Worm project, which aimed to accurately simulate the primitive nervous system. And he's also worked with Global Drug Survey looking at drug patterns, use of drug pattern usage. So, and of course, the thing he's done most recently, and the reason that we're all here, is the kind of groundbreaking study that he designed working with Imperial College and Beckley, and that is the self-blinding microdose study. And with that, I'm going to hand over to you, Balázs.
Thank you very much, Anna, for the kind introduction, and hello, everybody. Okay, so let me just share the screen with the audience. Okay, so let's get going. So first of all, before starting, I would just like to make a clarification with respect to what is microdosing and macrodosing. Usually people know it in the psychedelic scene, but in case we have people who are not insiders within the psychedelic community, I would just like to be to make it really, really clear that these are two completely different ways of using psychedelics. So typically when you hear about psychedelics in the news, all of the positive news that we hear about trials with respect to psychedelics, they are almost always with respect to macrodosing. So macrodosing is when you do a relatively large dose of psychedelic agent embedded within a therapy. So typically there is a 3 months long talk therapy, and within that there is 1 or 2 sessions of psychedelic drug usage. So the point is that with macrodosing, it's a few times embedded within therapy and large doses. Now, in contrast with that, what I'm going to talk about today is microdosing. And microdosing is when people are taking very low dosages of psychedelics, but frequently, multiple times a week, most frequently 2 to 3 times. So just to give you some ideas, so when we are talking about the therapeutic application of psychedelics, let's say LSD, then we are talking about 300 micrograms, like that's a typical therapeutic dose. When we are talking about microdosing, we are talking more about 10 to 20 micrograms. So the dosage are much, much smaller. And the typical recreational dose, somewhere between 100 to 200 micrograms, that sits somewhere in the middle. So just to give you some ideas, what are the relative dosages with respect to the therapeutic dose, the recreational dose, and the microdose that we are going to talk about today. So microdosing is a phenomena that have picked up, I think, somewhere in the mid-2010s, probably due to the work of Jim Fadiman. He's the one who popularized the concept, although it has been around before that. And in that period, microdosing has become this massive pop culture phenomena. But there's not a whole lot of scientific research on microdosing. And really the reason for it is that experimenting with psychedelics is still very expensive to do. And people who are investing in psychedelics, they are still in the phase of developing the macrodose therapies. And therefore, there has been little attention paid to microdosing. So that's microdosing is. And the other important concept that I would like to talk before getting to the study itself is what exactly is self-blinding. So as you can see from the presentation's title, we are going to explore microdosing with self-blinding methodology. So what exactly is this self-blinding? Now, blinding has a very specific meaning in scientific and in medical research. And blinding refers to that neither the patients nor the doctors or the evaluators are aware of the drug condition that the patient is receiving. Now here with self-blinding, the concept that we have developed is that the participants themselves are doing the blinding themselves. So typically in placebo-controlled studies, the patient goes to a doctor and he or she is going to receive either an active medication or a placebo capsule without either the doctor or the patient knowing it. But the point is that this placebo control happens in the clinic. The patient goes to the clinic, and that's where he or she gets the capsules. Now, what's new here is that we have developed a methodology, the self-blinding, how self-experimenters at home can include placebo control in their microdosing routine. I am not going to have time to go over all the details of how exactly this self-blinding is working, but I want to give the audience a high-level overview so that you roughly know what is going on.
Bella, I'm really sorry. I'm not sure, but I think the slides might not be moving. We're still on, well, what I can see.
Yeah, I'm switching now.
Oh, okay, phew. Wasn't
okay.
sure, sorry.
No. It's all good. Okay, so how is self-blinding working? So the first step that participants have to do is to put their microdoses inside non-transparent gel capsules, as you can see it on the picture. Now, the study was primarily designed for LSD microdosers, but there was a variant where psilocybin-containing mushroom could have been used. But for simplicity, I'm just only going to go through the LSD version of the study. So the LSD microdoses, which is just a small piece of the blotter paper, had to put inside these non-transparent gel capsules, and then these capsules were closed. And it's critical that the capsules were non-transparent because this ensured that we can use empty capsules as placebos throughout the study. So first, participants prepared these microdose-containing capsules, closed them, and put it aside. And then they prepared a separate set of capsules that had nothing inside. And since the capsules are non-transparent, later on, the users couldn't see what is inside the capsule. Is it an empty capsule, or is there a microdose sitting inside? So once these two set of capsules were set up, this is where a lot of the details I'm going to be ignoring, but basically these capsules had to be put into envelopes in certain order, together with some QR codes, and then these envelopes had to be shuffled, had to generate random numbers. Depending on what random numbers were given to the participants, they had to scan back some of those QR codes from the envelope, so on and so on and so on. But the net result of the setup is that participants ended up with capsules enough for 4 weeks without knowing which of those capsules are empty inside, i.e. placebos, and which of those capsules has a microdose inside. So that's the high-level overview of the self-blinding methodology. But really the point is that throughout this entire process, we have never seen the participants. This is something that they did it at home on their own. We have provided a manual for how to do the self-blinding, and there was also a video available how to do it, but we never see the patients in person. And this is quite a novel concept within the framework of placebo-controlled studies. Now, before starting to talk about the results themselves, I would like to go through the structure of the study so that later on, when I'm going to talk about the results, it is going to be clear what I'm talking about. So first, let's have a look at the top timeline that you can see here. And what we have in the blue frames, those are the measurements that we have called the accumulative outcomes, because they measure the accumulative effects of 4 weeks of microdosing. So the way the experiment works is that first there was the week 0 before the microdosing when the baseline measures were taken. And then there was the 4 weeks long dosing regime. And after that, we had the post regime week 5, which was the primary endpoint of the study. And then later on, there was also long-term follow-up, but I'm going to ignore that for the purposes of this presentation because it turned out to be not so interesting. Okay, so we have the primary endpoint or the primary outcomes were the change from baseline to week 5. But what was happening here in the dose regime during weeks 1 and 4? So as a part of the self-blinding process, participants have randomized themselves into one of 3 groups, with being in any of the groups have equal probability. So the first one is the placebo group that you can see on the left. And these people were just taking placebo capsules for the entire duration of the 4 weeks long dosing regime. Here at the bottom, you can see that the blue denotes the placebo capsules. Now in the middle, we have the half-half group. And the half-half here means is that they were taking microdoses for 2 weeks and placebos for 2 weeks, hence half-half. Now, one thing that some people get confused about is that if you look at the top line, the first week of the half-half group, you can see that there are some red capsules which denote the microdoses and some blue capsules are placebo capsules as well. So even though the first week was a microdose week, participants were still taking some placebo capsules during that week. And there's a reason why it was set up this way, but I don't want to get into that in the interest of saving time. And also later on, when I'm going to present the results, I'm not going to talk much about the half-half group, again, because it is not so interesting. What is actually turned out to be the most interesting is the placebo group and the microdose group, which what you see here on the right. So the microdose group are the people who were taking microdoses for the entire 4 weeks long duration. So they were taking 2 microdoses per week, so 8 microdoses overall during the 4 weeks long dosing regime. So as I said, the primary outcome was the change from baseline to week 5. But as you can see, we also did some measurements during the dose period. So what you see here in the green frame, that is what we call the acute outcomes. And the way that these have worked is that the participant was taking a capsule in the morning, again, without knowing whether there is a microdose inside or if it's an empty capsule. And then we asked them to complete a set of questionnaires 2 to 6 hours later. So they were under the influence of the microdose, if it happened to be the microdose capsule that they were taking. And then here in this purple-ish, pinkish frame, what we have are the post-acute outcomes, which is basically the day after your last capsule. But what's important here is that these were taken on Sundays, and on Sunday they never take a capsule. So they are not under the influence of either a placebo or a microdose capsule at that point. And the study was really set up this way because we wanted to capture the effects of microdosing on multiple timescales. So with these acute effects, these roughly correspond to the effects that are the daily effects. With the post-acute outcomes, that is for the weekly effects. What are the effects of microdosing that are emerging after a week of microdosing or a week of taking placebos? And then here at the top with the blue frame, those are the accumulative outcomes. What are the emergent effects after 4 weeks of taking microdoses? So that's it. Now we can really start to discuss the results. And the first result is actually the study flowchart. And I'm not going to talk a lot here, but I have highlighted for you one number, which is very, very important here. And that is that 191 participants have completed this study. And this actually makes this study easily the largest placebo-controlled study on psychedelics to date, and actually by a very wide margin. The second largest placebo-controlled study on psychedelics had 80-something participants. So this study is easily twice as big as the second largest. And this is due to the self-blinding methodology. This is because it was not a clinical study, but rather a global study run through the internet where everybody could set up his or her own placebo control. So obviously, this is something that we are pretty proud of, that even though this started out as a hippie project, we still managed to be the largest placebo-controlled study on psychedelics today. Now, another number which is important here is this 80%, and that is that 80% of the people who have started the experiment have finished it. And if you have seen similar survey-based studies on psychedelics run through the internet, their retention rate is typically 50%. Here it's 80%, meaning that we have managed to retain much more of the users compared to the other studies. And I think this is believed that this study involved really playing a game that you have to guess whether your capsules were placebos and microdoses. And we try to gamify it a bit, so to make it more interesting for the participants. Anyway, that's enough about the study flowchart, and let's go to the actual scientific results. So first, I want to talk to you about the accumulative outcomes. And remember, this is the change from baseline to after the 4 weeks long microdosing regime. And it's important that the accumulative outcomes were defined as the primary outcomes. And really the reason for that is because if microdosing would happen to be a good antidepressant, then this is the outcome that you are interested in. It's less interesting whether a substance can help you to acutely feel better. Cocaine would be a good antidepressant in that case. Whereas the real question, whether it makes you feel better after using it, but when you are off drugs. And just one more sentence, which I think is important regarding the selection of the outcomes that I'm going to describe here. So before we ran the actual study, we did a small-scale pilot study with 8 to, I think, 10 microdosers. And we basically showed them a bunch of psychological questionnaires. And we asked them to select for us what are the questionnaires that they think best captures the positive benefits of microdosing. And what I'm showing you here on this scale, the well-being scale, the RPVB stands for Riff Psychological Well-being Scale. That is something that was very strongly selected by microdosers, that this questionnaire captures the effects of microdosing very well. So what do we see here? So if you come down here to the x-axis, here you see that we have first the pre-regime, which is the same as the baseline. Then they do their microdosing here, and then we have the post-regime, the week 5 time point that I have showed you. We also have this follow-up, but as I've mentioned before, I'm going to ignore that because it turned out to be not so interesting. So first, what I would like to do is just to focus on the microdose group. So what you see here with red. You can clearly see that it is increasing. And if you look at the error bars, you can guess that it's going to be a statistically significant increase. And indeed it is, as I give you with this star notification at the top. So what that means is that microdosers in the study have significantly improved their own well-being after 4 weeks of microdosing. I think it's important to emphasize that this finding in many ways validates a lot of the anecdotal evidence about microdosing. However, the story is going to get a lot more complicated, but I also think much more interesting when you are considering the placebo group, what is shown here in blue. So remember, these are the people who were taking placebo capsules for the entire 4 weeks. Now, if you look at it, it increases. It actually increases about half of what the microdose group increases. And if you look at the error bars, you can see that the difference between the improvement in the microdose and the placebo group, it's not going to be significant anymore. And this is a very interesting finding because remember that relative to the baseline, microdosers have improved significantly, but they have not improved significantly relative to the placebo control group because participants in the placebo control group have also improved. Now, I know that the microdose group is still higher and then the blue is lower, so the microdoses improve more than the placebo group. But if you see at the error bars, there's a very, very large overlap, signifying that in a statistical sense, there is no significant difference between the magnitude of the improvements in the microdose group and in the placebo. Now, this pattern, these two findings that the increase relative to baseline is significant in the microdose group and the lack of between group difference between the placebo group and the microdose group, it wasn't just true for this one scale, but it was actually true for all of the psychological outcomes that we have measured in the study. So here I show you the same well-being scale as on the previous slide. In the middle, we have mindfulness. Again, you can see that for the microdose group, it shoots out very high above the baseline. But if you look at the placebo control group, it also improves significantly. And again, the difference is not going to be significant between the microdose and the placebo group anymore. The exact same story with life satisfaction, the exact same story with paranoia. With obviously paranoia, you want it to be lower. So here the dropping scores are indicating an improvement. Now, I left this here for the last, the cognition, because this is actually a little bit different compared to the other ones. So the previous measures are all self-reported psychological outcomes, meaning that participants went online and they had to fill out a questionnaire regarding their well-being. It's the scientific version of how are you doing. But with the cognitive tests, we have actually used a proper online cognitive testing platform where participants had to play online games designed to measure cognitive performance. Think about those memory card games that probably all of us were playing when we were kids. Or like one of the other tasks was the number of digits that can be recalled in reverse order, or how well you can match geometric patterns by mentally rotating them. We had cognitive tasks like these. We actually had 6 of these tasks, and we have aggregated the scores from those individual subtasks into what we call the CPS, the cognitive performance score. Now, the point here is that these cognitive scores, they are more objective compared to the self-reported outcomes. Your reaction is a more objective measure rather than when we are asking you about your well-being. Simply with the self-reported psychological outcomes, they are much more susceptible to the placebo effect because of their subjective nature. And because of that, this cognition, it works a little bit different. So actually, one of the differences that you can see that here at the microdose group did not improve even relative to their baseline. So when we looked at the microdose group alone, for the psychological outcomes, there was always the statistically significant increase. But here, with these more objective outcomes, even the change from baseline is not significant anymore, which really should make you suspicious regarding that there is a strong placebo response going on here. So this is the story with respect to the accumulative outcomes. And next, I'm going to move on to talk about the acute and the post-acute outcomes in this study. So one thing which is important to start with is that when the acute and the post-acute outcomes were measured, the last question, we always ask participants to take a guess. What do they think? Was their capsule earlier than the microdose capsule, or was it a placebo capsule? And with the post-acute outcomes at the end of the week, the question was whether they thought that this week's was a microdose week or a placebo week. So we had this guess information, and we analyzed the acute and the post-acute outcomes in 2 rounds. And first, we analyzed it without this guess information that I have just told you about. So if you look at this table, and in particular, if you look at the last column, you can see that there were several measures where there was a significant placebo to microdose difference. So for example, we used PANAS, the positive and negative affection scale, which is an acute emotional state or mood measurement. And you can see that there is a statistically significant difference, but the 2.2 difference is practically very, very small. And another way of saying that is that the Cohen's d, so the effect size, it stays below clinically significant. So here I give you the values of the Cohen's d calculated for it. Cohen's d is a statistical measure very often used to define the effect sizes. And it is by convention that a difference between a treatment and placebo is clinically significant if this Cohen's d value is larger or at least around 0.5. Now here, with respect to the PANAS scale, the Cohen's d is not even 0.2. So even though the difference is statistically significant, but the difference, the magnitude of the difference is so small that it's less than half of what is normally considered a clinically meaningful change. And this actually stays very much the same for all of the measures. The Cohen's d is almost always very, very small. It is just that because we had this very, very large sample size, we were able to detect even these very minute differences in the data set. Now note that there is one exception to the small Cohen's d, and that is this drug intensity VAS, and I'm going to come back to it very, very shortly. For those who do not know, the VAS stands for Visual Analog Scale. So this is when you have to move a slider between values of 0 and 100. So this drug intensity visual analog scale, that's the only measure where there was a Cohen's d which had a clinically meaningful change. So as I said, these outcomes were measured in 2 batches, first without the guess information, and I'm going to move on what happens when we add in that guess information. So what's cool with that is that it allows us to look at the data as 4 categories, where the 4 categories are formed by the drug condition and the guess. And that is what you can see here. So here at the bottom, you see the condition, which is the actual drug condition, what was in the capsule, and its values are either placebo or microdose. Now below that, you have the guess, which is the guess that I mentioned before, what you think you were taking. Also, it can have values of placebo and microdose. So here I show you the data for the PANAS, and I think it's worth going through what is going on here. So here in the leftmost column, that is when participants were taking a placebo and they were guessing that it was a placebo. And then the value in this PANAS scale is, as you can see, it's around 13. That's the baseline, so to speak. In the second category, that's when the participants were taking a microdose, but they were thinking it's a placebo. You can see the score goes up, but the error bars really overlap, and probably you can just see that this difference is not going to be significant. Now, the really interesting bit is when you look at the third category, when a participant was taking a placebo, but he or she thought that it was a microdose, then the score goes up all the way to 19, and it stays about the same when a participant was taking a microdose and thinking that it was a microdose as well. So what's important to notice here is that you can see that it seems to be that the data falls into two categories, the first two columns and the second two columns. But notice is that the change in the categories, the change in the score, they do not seem to be going with the condition, they seem to be going with the guess. It seems that the condition doesn't really influence what is the actual outcome. What seems to be influencing is a lot more is the guess. So this indicates that what matters is not so much the actual drug condition, but what the participants were thinking that he or she is taking. So let's analyze this a little bit further and put some numbers on it in terms of p-values. So what I show you here on these two figures is the exact same data as before. And first, I would like you to focus what you see here just on the left. Yeah. So what is going on here is that we are going to fix what is the value of the guess. So we are only going to consider data points when the participant was guessing either placebo or microdose, and then compare whether the condition made a difference after we have fixed the value of the guess. So what you can see here is that I'm showing you with the green that the guess is constant. And in this first comparison, you can see that the value of the guess is fixed at placebo. And then within that data, we are comparing the placebo versus microdose drug condition. Now, as I said before, you can see from the error bars that it's probably not going to be significant. And indeed, I give you the p-value at the top, which is 0.26, suggesting that there is not a statistically significant difference between the placebo and the microdose condition once you have fixed the value of the guess. Now, what you see here on the third and the fourth column on the left figure is the same as before, but now we are fixing of the value of the guess not to be placebo, but to be microdose. And again, within the fixed guess condition, we are just comparing the placebo and the microdose condition. Again, you can see the error bars overlapping very highly. And again, you see that the p-value is not significant, suggesting that the condition does not make a difference once you have accounted for the guess. Now, what you see on the right side is the exact same analysis, but we are reversing the role of condition and guess. So in this case, we are fixing the value of condition and comparing guess. So what's going on here on the comparison of the first and the second column in the right figure is that we are considering only when the condition is placebo, so when a participant was taking a placebo capsule, and then comparing the cases when the participant was guessing placebo or microdose. And you can see that this difference is very, very highly significant. And it's the same story with the comparison of the third and the fourth column, just that in this case, the value of the condition is fixed to be a microdose, and we are comparing the placebo and the microdose gas cases, and again, finding that the difference is very highly significant. So what this provides evidence for is that with respect to these outcomes, what matters, it's not the actual drug condition, but what the participants thought that he or she is taking. And this pattern that I'm describing here, it is very, very consistent throughout all of the acute and the post-acute outcomes. What I show you here, this is for the aforementioned PANA scale, but it is practically the same for all of the other scales that we have measured. So we had 11 outcomes, either acute or post-acute. And once we have fixed the guess, there was only one case when the comparison was significant, suggesting that there was only one outcome when there was an actual true drug effect once you have accounted for the guess. Now, with the reverse analysis, when we are fixing the value of condition, then 10 out of the 11 possible comparisons were significant, suggesting that once you have accounted for the drug condition, the guess is always significantly different. So there is basically one exception to both rules, and it's fascinating what are the exceptions. So here on the left side, the left figure, when the guess is constant, that is what would be indicative of a true drug effect. And that is one outcome, which is the drug intensity VAS that I have mentioned when we were looking at the table. So that is the only variable that have survived this adjustment for the gas, suggesting that there is a true drug effect in microdosing, and it emerges, or participants have noticed it as increased drug intensity. And later on, once we realized this, then we went back and asked participants what did they mean exactly by drug intensity. And it's things like slight tension in the muscle or bodily sensation, slightly increased saturation of colors in the visual field. So everything that typically is also associated with a full dose psychedelic groups, but here obviously the effect, also the magnitude of the effects are much smaller because we're talking about the microdosing. But again, there is one true drug effect, and that is the drug intensity, which opens up the possibility that microdoses can be functioning as an active placebo. Now here on the right side, when the condition is fixed, there is also one exception, and that one is the acute measurement of the aforementioned cognitive outcomes. So I've highlighted that for you here in red. And again, this is super fascinating because remember that cognition was the one outcome which is not based on self-reported questionnaires, but rather which is something which is a more objective measure. And in this case, for the acute cognitive performance, neither the condition nor the gas makes any difference. For all of the other outcomes, all of the other psychological outcomes, basically the condition never makes a difference, but the gas always makes a difference. So this is just some of the outcomes that we have measured, but these are the important outcomes. So again, the PANA scale for acute emotions, we had an acute mood VS. This is the anxiety scores, depression scores, the VMWeb, I forgot what W stands. So the Warwick Edinburgh mental well-being scale. All of these scales are showing the same pattern, that condition doesn't make a difference, but gas does. So that's really the results. And oh, sorry, going the wrong way. So before opening up for questions, I would just like to summarize what I think is the overall interpretation of this study. So obviously one of the questions, so based on it, does MDing work? And, I think that's really a tricky question because, especially, when you are talking to the popular media, they want you to, they want that, to be told whether microdosing works or not, as if that would be a very simple binary answer to that question. But the situation is a lot more complicated here. So remember that when we talked about the accumulative outcomes, that for all of the psychological outcomes in the microdose group, the scores increased in a significant manner relative to the baseline, suggesting that microdosing really does increase all of these psychological outcomes, and microdosing does work in that sense. However, what makes this a lot more difficult to interpret is that if participants who were just taking deceptive placebos for the same 4 weeks long duration, they have also improved equally, and there was no statistically significant difference between the microdose and the placebo group anymore. So, does microdosing work? It really depends on what you mean by works. It improves microdosers relative to the baseline, but it does not work better than taking deceptive placebos. So I think what's going on here is that I 100% believe that the benefits of microdosing are real. So our study in many ways validates all of those anecdotes about microdosing that are on the internet and that I'm sure that many of you are aware of. Microdosing does increase all of psychological outcomes. Our data is very, very clear about that. But the data also argues that you can reproduce those effects just by taking deceptive placebo capsules, suggesting that the microdose inside the capsules is not a necessary component for these positive outcomes. So I think is how to interpret that is that the benefits of microdosing are real, but the mechanism behind that is likely not due to the pharmacological action of microdosing. Rather, psychological expectation effects are sufficient to explain or to reproduce those benefits. Now, no study is perfect, and this was not a perfect study for sure. So the major limitation really is that this was not a clinical study, it was a citizen science project where participants had to source their own drugs, and psychedelics being widely illegal, that has meant that people have sourced it from the black market, leading to uncertainties with respect to the purity and the exact quantity of the psychedelic substance consumed as microdose. And obviously that's a limitation, I'm not denying that, but one thing which I think it's important to realize that basically everybody who is microdosing like that. Because because psychedelics are widely illegal, everybody is sourcing their psychedelics from the black market. So it's not like that our study is an outlier that our microdosers are sourcing their microdoses from the black market. That's generally true for microdosing. So I think the right interpretation of this study is that this is not a clinical study. It's clearly not. But I'm very comfortable saying is that our results are representative of real life microdosing. What are the likely effects of real people in real life going on about their everyday life, how microdosing is going to affect them, with all of the variability and uncertainty that is just imposed by having to source your psychedelics from the black market. Another important point that I would like to say is that the sample was very healthy. So there were very few people who had any diagnosed mental health condition. And one place where I'd see that microdosing could be effective is testing it in a clinical population, so people who are depressed. Obviously, with this design, and because of the citizen science nature, it would have been ethically difficult to recruit people who have a diagnosed depression. We did an analysis in the paper where we have analyzed separately people whose baseline depression scores, the baseline well-being scores were at the bottom 25%, and we analyzed those separately, and we did not find any difference compared to the overall analysis. All of the qualitative results were the same as what I just told you with respect to the entire sample. So our data is not, makes it look promising that results will be different in a clinical population. Nonetheless, I wanted to highlight is that this population was healthy. So last but not the least, I would just like to highlight that ignore microdosing. Like, that's not the story here. I mean, I know that LSD and microdosing are exciting right now, but the story of this paper, it's not that, it's the self-blinding methodology. Because what we have managed to work out here is a really cool methodology which allows you to recruit a very, very large sample, because everything is run through the internet. You never have to see the patients in person. And our sample size backed this up. Again, this was the largest placebo-controlled study of psychedelics to date. And not only the sample was huge, but the study was incredibly cheap. And it was cheap again because it was a citizen science project, because you didn't have to pay for the doctor's time. That basically what reduced the cost. This study costed less than $10,000 US. And if you know anything about research, you know that is incredibly cheap. If we would run this study with 200 participants as a clinical study, then we would be easily talking about millions of dollars in terms of costs. So the costs of this study are basically 1% of an equivalent study. You can have the much larger sample than what is typically feasible in a clinical study, but you still have the placebo control. So the combination of these three factors is what really makes self-blinding really interesting. I think it's fair to say that, there are many ways to categorize studies, but by and large, medical studies fall into two categories. There are the observational studies and the clinical studies. And I think this study, why it's interesting is because in terms of the strength of the evidence that such a design carries, it's somewhere in between those two. As I said, it is clearly not equivalent to a clinical study because of all of the uncertainty with respect to the dosing. But it is also clearly better than a pure observational study where there is no placebo control condition. So typically we are thinking about either clinical studies or observational studies. And there are many differences between the two, but really the major distinguishing feature is the lack of placebo control in observational studies. And here we have found a way how to do citizen science projects that have better scientific value in terms of the way of the evidence they carried in observational studies, while the costs are remaining the same, and it has the placebo control, which is the major gap between the observational and the clinical studies. So overall, we are super excited about the future of self-blinding. And if there are any researchers on the call, we are looking for collaborators on this. So if you have any favorite intervention and would like to have a self-blinding study on it, please reach out. We are happy to collaborate. Right now, we are working on another self-blinding study to assess the efficacy of CBD oils, something which is also very popular, but there's not so much solid clinical evidence behind it. So I think that's going to be a really exciting study. And also we are planning a self-blinding microdose study version 2.0, which is going to be running on the Mydelica mobile platform. And it's going to come out towards the end of the year or early next year. That study running on a mobile platform allows us to do a lot of cool things that were not possible with the first version of the study. So last but not the least, I would just like to acknowledge my collaborators on this project. You're going to see some of the usual suspects here, but I would really like to emphasize the involvement of David Erizzo, who has been there with me right from the beginning. I worked with David on MDMA before, and when I had the idea for self-blinding, I called him up and he immediately jumped on it. And it took us many, many years to get to this point. But anyway, I could have not done without David, so I really wanted to highlight his contributions.